Welcome to the first section on factoring. In this section, we'll be talking about factor by grouping and factoring the greatest common factor. And first, we need to discuss factoring the greatest common factor, which will always be your first step required to factoring any algebraic expression. You always want to look for a greatest common factor. And what does that mean? So we've got a problem here for 48x to the third along with 32x to the fourth. So we're going to consider these as two separate terms, and what we want to do is find the greatest common factor. Now, greatest common factor, what it really means is a number and variables that divide into both expressions evenly. And you want to pick the largest common factor. So to do this, what we're going to do is factor the coefficients into primes. So I'm going to write this as 48x to the third versus 32x to the fourth. And what I'm going to do is factor trees. So I'm going to break down 48 into, let's use 6 times 8, or anything else that gives you 48 multiplied will work. 6 will also break down into 2 times 3. Now when I look at 2 is prime. It will not break down anymore except 2 times 1, and that's not really breaking it down, right? 3 is the same thing, it's prime, but 8 is not prime. 8 can be factored again into 4 times 2, and then 4 factors into 2 times 2, and these are the end of the branches. So that means 48 can be written as, notice there's 1, 2, 3, 4, 2, so it'd be 2 to the fourth times 3, and then the x to the third. Okay, so that's 48x to the third in prime factors. Now let's do the same thing with 32x to the fourth. So 32, I can write is 8 times 4, right? 8 is 4 times 2. 4 breaks down into 2 times 2, and that's the end of the line, and 2 is the end of that line, and this 4 is 2 times 2. And a lot of you already knew that 32 was 2 to the fifth times x to the fourth. Now, when you're looking for a greatest common factor, what you're trying to do is find what is in both of these, what's common to both. And so that's going to be the lowest exponents. Like there's 4 2's here and there's 5 2's here. Well, what's common is they both have 4 2's. So 2 to the fourth is part of our greatest common factor. This has a 3, but this one doesn't. Therefore, 3 is not common to both of them. We have an x to the third and we have an x to the fourth. And again, the smallest of the two is what's common to both of them. So there's an x to the third common. And I'm not supposed to leave 2 to the fourth as 2 to the fourth. I'm supposed to multiply it out. So 2 times 2 is 4 times 2 is 8 times 2 is 16. X to the third is your GCF, or greatest common factor for these two expressions. Now let's try it again and take a look at 54m squared into the third. I'm going to break 54 down into what? 9 times 6 is 54. 9 breaks down into 3 times 3. 6 breaks down into 2 times 3. Those are all prime numbers. So what that means is I could write 54 is 2 times 3 to the third, and I still have an m squared and an n to the third. Now let's work on 18, which is 9 times 2. And 9 is 3 times 3, and that's the end of the line. So I can say 18 is 2 times 3 to the second, and I still have an m and an n squared. Now remember, the greatest common factor is what they both have. So let's look at the 2's. They both have a 2 to the first and a 2 to the first. So a 2 is part of our greatest common factor. Look at my 3's. I have 3 to the third and 3 to the second. Again, what's common to both of them is the lower exponent, 3 to the second. And then I have an m to the second and an m to the first. So I have to pull out the smallest, which is the m to the first, and I have an n to the third and an n squared. Again, what's common to both is the n squared. Now I'm supposed to multiply that out. 2 times 3 squared is 9. 2 times 9 is 18. M n squared is the greatest common factor for those two expressions. Now, do you have to factor it into primes? No. We could have looked at 54 and 18 and noticed that, hey, 18 divides into both of those. Now, a lot of people would have looked at it and thought 9 divides into both of them, or 6 divides into both of them, but actually 18 divides into both of them. You have to pull out the biggest. And again, when you're dealing with variables, if they have a common variable, it's the smallest exponent. You got an m squared, an m to the first, so it's an m to the first that's common. An n to the third and an n squared, so it's an n squared that is common. All right, let's try this one more time when we're working with 3 algebraic expressions. It's not a polynomial or anything. We're not even adding or subtracting them. We're just looking at 3 different algebraic expressions and trying to find the greatest common factor, or GCF. So, first of all, you can look at 18, 36, and 72 and tell me what divides into all 3 of those, which in my thought it's 18. Or we can break it down. And then we'll look at our x's and do the same thing, our y's and our z's. But let's look at 18. Let's break it down into prime factors, just in case you didn't see that 18 divided into all 3 of those. So that's 9 times 2, which is 3 times 3. So we get 2 times 3 squared times x to the third, y to the third, z to the second. All right, so in a different color, let's take a look at 36. So 36, I say, is 6 times 6. 6 is 2 times 3. That 6 is also 2 times 3. So it gives us 2 squared, because there's 2 of them, times 3 squared, because there's 2 of them, times x to the fourth, times y squared, times z to the third. And finally, let's take a look at our 72. So 72 breaks down into 8 times 9. Maybe it's the first thing you thought about. 8 is 2 times 4. But 4 is 2 times 2, so that's the end of the road for those branches. And 9 is 3 times 3. So we've got, look, we've got 2 3s, so that's 2 to the third. We've got 2, did I say that right? We got 3 2s. I wrote it down right, I didn't say it right. So those 3 2s, that's 2 to the third. And there's 2 3s, so that's 3 to the second. And we still have an x, a y to the third, and a z to the third. Now, to find our greatest common factor, let's look at our numbers at a time. Let's look at our 2's. I have 1 2 here, our red has 2 2's, and our gray has 3 2's, which means we need the smallest of those, so we just need the 2 to the first, or just the 2. Now let's look at our 3's. We have 2 3's here, 2 3's here, and 2 3's here, so that's what we need. 3 squared, which is 9. Alright, let's look at our x's. I've had x to the third, an x to the fourth, and an x to the first. You have to pull out the smallest, so that's just an x to the first. I have a y to the third, a y squared, and a y to the third. You have to pull out the smallest, so y squared. I have a z squared in the green, a z to the third in the red, and a z to the third in the gray, so z squared is the smallest. And my greatest common factor is going to be 2. 3 squared is 9. 2 times 9 is 18. That's the 18 we talked about at the beginning. X, y squared, z squared. So that's my greatest common factor. Now we want to look at polynomials that have a greatest common factor. So our first example, like this, C, we have 3x as a term and 12 as a term. So you don't have to break this down into prime factors unless you just can't see for yourself what the biggest number that divides into both 3 and 12 is. But you know that's 3, right? 3 divides evenly into 3, and 3 divides evenly into 12. And so what you'll see is some people will write that number underneath each one like this. And that's okay by me, but I want to make sure you realize you have to write it in front of a set of parentheses. So you're pulling that 3 out. And when you take 3 and divide it by 3, that leaves x. And you take 12 and divide it by 3, that leaves 4. And the plus that's in between them stays in between them. So the answer to this is 3 times x plus 4. Now, you could check this, right? And I advise checking it. This is your answer. But to know if it's right, you could just distribute the 3 back in. So that would be 3x plus 3 times 4 is 12. So it checks out just fine. And that's the good news about factoring, is you can check every one of your problems by taking your factored result and expanding it or multiplying it back out to see if you don't get the original problem. So let's take a look at the next one. All right, so we've got 5m plus 15. Now I want you to think, what is the biggest value that divides into both 5 and 15? And y'all know that's 5. 5 divides into 5 evenly, it divides into 15 evenly, so I'm going to pull that out. Okay, and then if I divide 5m by 5, that leaves m. If you don't see that, remember the trick is just to put your greatest common factor underneath each one of our terms. And then the 5 cancel, that leaves m. And then 5 divides into 15 3 times. And the plus came because it's still a plus in between when you divide each of those by 5. Again, check it. You don't have to write it down, but 5 times m is 5m. 5 times 3 is 15. Of course it's right, right? Now 14p and 42, very similar to the last one. Because, pick a different color, folks, because 14 actually divides into both of those. Now, some of you might have thought, well, 7 divides into both of them. Let's write it down and see. If I pulled out a 7, okay, so 7 divides into 14 2 times, right? So that'd leave 2p. And 7 divides into 42 6 times. But look, we still have a greatest common factor. 2 and 6 can both be divided by 2. So that 2 has to come out front. So actually it was 14 that would divide into both of those. And that's going to leave p minus 3. Or right over here in the beginning, back here, when we divide each of those by 14, it just goes straight to there. The 14 comes out front, the 14's cancel, it leaves me p, and 14 divides into 42 3 times. Of course, you can distribute it back out to check yourself. Let's try it again. So I'm looking at two terms, 4x and 4. Now I know you see the 4. They both have a 4 in common. So the 4 is going to come out front of parentheses, no plus at all. This is multiplication. If I divide by 4 here and 4 here, these 4's cancel to leave me an x. And then 4 divided by 4 is plus 1. So I want you to see, when you pull the whole thing out front, that still leaves a 1 there. If that 1 weren't there, when you checked it, you wouldn't get 4x plus 4 back. You would just get 4x back. So make sure when you pull out the entire factor, it still leaves a 1. Okay? Now, 63 and 9, do you see they have a 9 in common? Right? I'm going to divide each of these by 9. 63 divided by 9 gives me 7, and then the n was already there, it's still there, and then 9 divided by 9 is 1. Notice that was minus, so we have a minus in between. Again, to check it, you could just simply distribute this back inside, and you would see that would give you 63n minus 9, which is exactly what we're looking for. Now this time we've got 3 terms, and that is perfectly fine. So I'm trying to figure out what number divides into both 4, 12, and 8. So what number divides into both 4, 12, and 8? And you all know that's 4. And they all don't have an x. This has an x squared. This has an x. So these two have a greatest common factor. But unfortunately, the 8 at the end does not have an x. So I cannot factor out a variable that's common because they don't have a common variable, all 3 of them. So the 4 is the only thing I'm dividing each of these by. This 4 and this 4 cancel. That leaves me with x squared. I didn't put my parentheses, don't forget about those. This 4 goes into this 12 3 times, so it's minus 3. And don't forget the x that's already there. And then 8 divided by 4 is 2, so minus 2. Now again, remember the check. 4 times x is 4x squared. 4 times negative 3x is negative 12x. And 4 times negative 2 is negative 8. Notice that was our original problem, so it checked out. Now the red is actually our answer. That is what we call factored, at least with the greatest common factor. Let's keep going. So we want to factor the greatest common factor from 9y to the third and 81y squared. Now look at one thing at a time. First, let's just look at numbers. So 9y to the third and 81y squared have a 9 in common. So definitely want to pull out a 9. And then y to the third and y squared. Remember, you're supposed to pull out the lowest of the exponents that are in common. So y squared can come out. Remember, you put parentheses after your greatest common factor. No operation in between. That's multiplication. Now, each one of these, I'm going to divide by 9y squared, right? So this 9 and this 9 cancel. Y to the third divided by y squared. Remember, you subtract exponents. 3 minus 2 leaves you y to the first. You can put the 1 there or not. Plus 81 divided by 9 gives you a 9. And then y squared and y squared, they cancel each other out. And there we go. Now again, to check yourself, you distribute it back. 9y squared times y is 9y to the third. 9y squared times 9 would be 81y squared. So that means we did it right, and we checked it too. Now the next one looks a little odd because it's got that negative in front of the 6x. And often when the leading coefficient, which is the negative 6 in this case, is negative, factoring out a negative greatest common factor is a good idea. So let's try that. So I'm going to, and by the way, 6 and 12 have a greatest common factor of 6, right? 6 divides into both 6 and 12 evenly, and it's the biggest thing. I mean, 2 divides into both of them, 3 divides into both of them, but you want the biggest number, which is 6. And since it's a negative leading, I'm going to pull out a negative 6, okay? So imagine I'm dividing each one of these guys by a negative 6. Now this negative 6 cancels with this negative 6. That leaves me with a positive x inside the parentheses. Now this, think about this as a minus 12 or negative 12 divided by a negative 6. That's going to leave me with a plus 2. So when you factor out a negative coefficient, okay, or a negative greatest common factor, then it's going to change your signs, both of them. Like this first term was negative, and now it's a positive x. The second term was negative, and now it's a positive 2. And if you checked it, remember the check, just distribute that back inside. So negative 6 times x is negative 6x. Negative 6 times positive 2 is minus 12. Notice it checks out just fine. So in red is our answer, negative 6 times x plus 2. Now, maybe pause and you work on the next one yourself. So hopefully, when you looked at this problem, you went, oh, okay, they both have a 5, so that should come out. And they both have x's. One of them has an x squared, the first term. The second term has an x to the first. Remember, you have to pull out the smallest of the common exponents. And since the leading coefficient's negative, let's pull out a negative 5, just like the last problem. And again, x to the smallest it shows up, which is just x to the first. And then we're going to have a set of parentheses after that. If you like, write negative 5x underneath each of these. That keeps you in line. Negative 5 cancels with negative 5. Oh, I didn't write the x. And then this x squared over this x to the first, remember you subtract those, that's just going to leave you with an x. That's all that's left on that first one. Now the next one, 5x divided by negative 5x, like boom, 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 all that cancels, but don't forget this positive divided by this negative right here, it's going to be minus, and when everything cancels, remember that leaves a 1. And if you check that, you distribute negative 5x times x is negative 5x squared, and negative 5x times negative 1 will be plus 5x. So it checks out just fine. That was our original problem, which means that has a greatest common factor completely factored out. Let's try one more of these greatest common factors, and then I'll show you something called factor by grouping, which uses the idea of greatest common factor. So this time we have 3 terms. So I'm going to look at just the numerical part of the coefficient. I got a 48, a 16, and an 8. If you think about that for a minute, I know 2 goes in all of them, but so does 4. But actually 8 divides into all of those. So when I pull out my 8, that's going to be one of my greatest common factors. Now let's look at the x's. X to the first, x squared, x to the first. That means I can pull out an x to the first. Look at my y's. I got a y squared, and a y to the first, so I can pull out a y to the first. And then directly after, parentheses. So each one of these terms is going to be divided by 8xy. And I'm pulling out a positive because the leading one was positive. So 8 divides into 48 6 times. And this x cancels with that x. And y squared divided by y to the first, you subtract those exponents to get y. And that's all that's left for that one. And the next one, 8 and 16, leave a 2. And there's a plus there, so that stays plus because I'm dividing by a positive. X squared over x leaves me with x. And y squared over y leaves me with y. Remember, you subtract those exponents. There's a 1 there and a 1 there. Now my last term, the 8's cancel, the x's cancel, the y's cancel, so I don't put anything, right? Well, no, that's a minus 1, okay? Take a minute to check it. Make sure it checks out. I'll do that with you. So this is my answer. Goodness, what just happened? We're back. Okay, so we're going to check our answer by distributing. Now our answer is here. Okay, and I'm going to check it by multiplying this inside here. So 8 times 6 is 48. X times x, oh, there's not an x here, so that just leaves me an x. Y times y is y squared. Then I'm going to do 8xy times 2xy. So that's going to be plus 8 times 2 is 16. X times x is x squared. Y times y is y squared. Then finally, 8xy times negative 1 will be negative 8xy. And you compare that to the original problem. Look up there. It's exactly the same thing. So we know that this is the right answer as far as factor by grouping. Greatest common factor. Now we want to start something a little new, but not really. This is called factor by grouping. And the example M is really not even factor by grouping. It's like the second step of factor by grouping, but it's factoring a greatest common factor. And I want you to take a look at these two terms. So this is multiplication, so think about that as one term. This is also multiplication, so think about that as one term. And what do those terms have in common? And I know you see what it is. It's x plus 2. So let's factor out that x plus 2, put it in parentheses. So remember, I'm dividing this one by x plus 2, and I'm dividing this one by x plus 2. So that cancels. So in parentheses after, this is what's left over, 4x, and then those cancel, plus 3. Okay, so when you do this step, when you have a set of parentheses that's common, you factor that out, and notice what's left, your answer, is what's out front, which was 4x plus 3. That's what we have right here, 4x plus 3. Okay, so the one that matches, I always put that in front, and then what's left over is the second set of parentheses. Now, there's nothing wrong with putting 4x plus 3 first, and then times x plus 2. That is perfectly fine. Now, on example N, it is an all the way through factor by grouping problem. So notice these 4 terms, and notice there's 4 terms. That's how you often recognize a factor by grouping, but they don't have anything in common. Like, none of them have an x and a y. None of them have a 3 or a 4 as the greatest common factor, but we can group them together. So what I want you to do is group those two together and those two together. Now, if you don't like your grouping, you can move your terms around, but if something factors out of the first set and something factors out of the second set and it matches like it did in the problem before, then you're doing just fine. Now look at this first set. They both have a y in common, so I'm going to pull that y out. So remember, I'm dividing that by y and that by y. So when I do that, that leaves me with x plus 3. Okay, now I'm going to look at my second set. They have a 4 in common, right? So it's a positive 4. I need to put plus 4. Now you're not used to doing that in front of your greatest common factor, but there's still a plus right here. So we need to put a plus 4. Now, if I divide that by 4 and that by 4, that's going to leave me with parentheses x plus 12 divided by 4 is 3. Now here's what you're looking for. You're looking for what's in the parentheses to match. It has to, or factor by grouping is not working for you. Okay, so remember the next step was to write down the one that matches, which is x plus 3, times what's remaining out front, which is y plus 4. Now the mistakes people make is like the one that matches, they want to write that down twice. You don't, because you're factoring it out. So when you factor out this x plus 3, remember you're dividing this by x plus 3, you're dividing that by x plus 3, those cancel, and you're just left with parentheses y plus 4. All right, let's try this again. So the first set and the second set. But now always look for a greatest common factor. And when I'm looking, you know, I don't see, there's not an x in every one of these terms. There's not a y in every one of these terms. There's not a 7 that goes into every one of these terms, or a 3 or a 21. There's no way to divide all 4 terms by the same number. So what we're going to do is group them together. Now again, these first guys, they have an x in common, so I'm going to factor that out front. So here's my x. Remember, I divide that by x, divide that by x. That's going to leave me with y minus 7. These two guys have something in common as well, a 3. I divide that guy by 3 and that guy by 3. All right, and it's 3. But now I can't just put 3 right here because there's still a plus 3. And that's going to leave me with y minus 7. Now, notice, this is the important part. We do have the matching factor. If you don't have a matching factor, then you've either done something wrong or factor by grouping just doesn't work. So we pulled out a y minus 7. What's left over is x plus 3, and we're finished. Now, what we haven't done is we haven't checked any of these, but we could sure check it. Let's do that, okay? So to check it, I'm going to multiply this out. So y times x is, I'm going to write it as xy. Yx is fine. Y times 3 is 3y. Negative 7 times x is negative 7x. You know what method I'm doing, right? The full method. Negative 7 times 3 is minus 21. Is that my original problem? Notice it is. Now, it's in a different order. Is that okay? Well, sure it is. Remember, you can rearrange the order of your terms. That's actually called the commutative property of addition. It is okay to rearrange the order. So, yeah, we checked out. And you could check the other two as well, just to make sure you did them right. Here we go, our last page of problems. So I look at my 4 terms. That ought to be a clue to, hey, factor by grouping might be the way to go. But before you even get that far, make sure all 4 terms don't have a greatest common factor. And these don't. They don't all have a z. I can't divide a number into all of them, but I can group the first 2 together and the last 2 together. Now, the first 2 have a z in common, so I'm going to pull that common z out. Remember, if you have to write divided by z on each of them, you go right ahead. It's going to leave me with z plus 6. Now, here's the deal. Over here, they have a 3 in common, but I think if you just factor out a 3, it's going to leave you with negative z minus 6. Which doesn't match what we have here. So I'm going to pull out a negative 3. Remember, now when you divide by a negative, your operations change. Negative 3 divided by negative 3 is positive z. Okay, so that's just z. And then this negative 18 divided by this negative 3 is plus 6. And look, they match. Z plus 6 and z plus 6. I'm supposed to write down the one that matches, z plus 6. Times what's left over when I factor that out, which is going to be z minus 3. And that is completely factored. Feel free to check it. I'm going to move along so the video doesn't last forever. But that's how that works. Let's try another one. Okay, now I'm looking at all 4 terms. Is there anything in common to all 4 terms? And there's not. I know you're thinking, well, all these have a p, and they do, but not the 27, so no greatest common factor. So anytime I see 4 terms, I try factor by grouping. It may or may not work. Here, there's a p in common. That leaves me with p minus 3. Here, there's a 9. There's a 9 in common. Now, if I just pull out a 9, that's going to leave me with negative p plus 3, which is the opposite of what I need. So let's pull out a negative 9. That's going to leave me with p minus 3. Remember, when you divide by a negative, it changes the sign. So these 2 negatives cancel to leave you a positive p. This positive 27 divided by negative 9 is minus 3. Don't stop there either. Here's another mistake people make. They get here and they circle their answer like they're done. This is not factored because of the subtraction in the middle. Okay, so you have to write down the one that matches, which is p minus 3, times what's left out front, which is p minus 9. But that really is just a greatest common factor step. And I've got one more problem down here before we wrap up the video that I want you to take a look at. And I want you to compare these 2 problems together. Okay, right here, I don't see anything common to all of these. I see lots of 7s and 2s, but and x's in the first 3, but the last one doesn't have an x, so let's group the first 2 together and the last 2. Now when I pull out I can pull out an x squared here. 7 and 2 don't have anything in common, but they both do have an x squared. So if I divide that by x squared and that one by x squared, right? So I have parentheses. That's going to leave me with 7x and then minus 2, because the x squares just cancel. Now remember, I have to be left with 7x minus 2 on this one as well, right? So, but right now it's the opposite of that. It's negative 7x plus 2. So I have to factor out a minus 1, and that's going to change that to what we need, 7x minus 2. Those get people all the time. Now don't stop there, you're not finished. You have to write the one that matches, 7x minus 2, times what's remaining out front, which is x squared minus 1. Now in the future, we're going to be able to factor x squared minus 1 more. But right now we don't have those skills. We're just doing factor by grouping and greatest common factor. And I wanted us to compare that problem to, let me find a different color pen to use, but to this one, which looks very similar. Notice the difference is our signs. This one's negative 7x plus 2. This one's negative 7x minus 2. Again, nothing common to all three, so I group these together and group those together. Here, they both have an x squared in common. It's going to leave me with 7x minus 2. It's exactly like it was here. Now, if I pull out this negative, negative 1, that's going to leave me with 7x plus 2. Well, look, folks, this one and this one don't match, so that's not going to work. Well, okay, let's try it again. X squared, and that leaves me 7x minus 2. So let's pull out a plus 1 then. Plus 1. Well, that's going to leave me with, if I pull out a plus 1, it's going to leave me with the same signs I have here, which is negative 7x minus 2, and they still don't match. So what's going on? Well, this one's not factorable. So I want you to think that every problem with 4 terms is factorable. Many, many, many problems are not factorable. It has to be the right circumstances, so you have to be able to recognize those. Hope this video helped you out. Have a great day.